Here is another example where we are going to calculate some probabilities. In this example, we will be using the multiplication rule and the addition rule. So here's the example. According to a study, 11% of adults in the United States are left-handed. If 2 adults are randomly selected from the US, A, find the probability both adults are left-handed. B, find the probability that both adults have the same handedness. So this means they're either both left-handed or they are both right-handed. So let's go ahead and answer the first question, A, which is to find the probability both adults are left-handed. So the probability that we have the first adult is left-handed and the second adult is left-handed. So here you can see I have an and statement, so I'm going to use the multiplication rule. I'm also going to notice that since I'm selecting the adults from the US, I can consider the 2 draws to be independent. So this is because I'm selecting from a large population. I can consider these 2 to be independent events. So I'm going to be using the multiplication rule for independent events. And that tells me that this probability, the probability of both individuals being left-handed, is equal to the probability of the first person being left-handed times the probability of the second person being left-handed. And in this case, we know that that is 0.11 times 0.11, which is equal to 0.11 squared, which is equal to 0.0121. And I can also write this as 1.21%. So there's a little over a 1.21% chance that both of the randomly selected adults would be left-handed. So let's take a look at the second question. Find the probability that both adults are the same handedness. So as I said, this can be translated as the probability that both are left-handed or both are right-handed. Okay, and then this, when I see the or, that immediately makes me think of the addition rule. So I'm going to, and I'm also going to note that selecting both individuals being left-handed and both individuals being right-handed, these are disjoint events because they can't occur at the same time. If both individuals are left-handed, they can't also both be right-handed. So that allows me to use the addition rule for disjoint events. Okay, and in this case, we have the both left-handed. I'm going to write this as left and left. So they're both left-handed plus right-handed and right-handed. Okay, so we've already calculated the first probability, and we know that that's 0.0121. So I'm just going to work on calculating this probability right here, that they are both right-handed. So that's using the addition rule for independent events. This is just going to be the probability that the first person is right-handed times the probability that the second person is right-handed. And so how am I going to calculate this probability? Now, I know that the probability of an individual being left-handed So what is the probability that an individual is right-handed? So we're going to have to use the complement rule. And we're going to be using 1 minus the probability that the individual is left-handed. So that would be 0.89. And if I multiply these, I get 0.7921. And adding these together, I get 0.8042. 80.42% chance that the individuals have the same handedness. In other words, that they're both left-handed or they are both right-handed.